to introduce Kim Hackett of Silicon Valley Clean Water. She has a title that I always love, Authority Engineer. It just intrigues me. But anyway, she is the authority engineer of Silicon Valley Clean Water. She's been pretty busy lately. She's responsible for the engineering, lab, and environmental services divisions, and also been responsible for the capital improvement program, which is huge, and a complete rehabilitation of the wastewater treatment plant, plus a major regional environmental sewer conveyance upgrade, and I think that's called, excuse me, RESCU, R-E-S-C-U program. Kim has over 20 years of experience in planning, design, construction management, and project management of wastewater and recycled water projects, both as a consulting engineer and public sector worker. So take it away, Kim. That was the menu. And
thank you.
Forward is there.
Is there a...
And there's a green laser pointer.
Who participated yesterday online may have seen the presentation by Sebastian Tillmans about the Safe MBR pilot that is at our at Silicon Valley Clean Water's facility. I unfortunately missed it. He always is. He's such a great speaker, and he's always doing such interesting things. I can't promise that this is going to be as exciting of a presentation, but I'll try, and I guess I'm trying to wow you in file size. Okay, so this is me. Okay, very good. So we are Silicon Valley Clean Water. We are a joint powers authority, which is why I happen to have the title Authority Engineer. It's the chief engineer or district engineer, but we're not a district, we're an authority. So we are a JPA, and we do the wastewater conveyance and treatment for Belmont, San Carlos, Redwood City, and West Bay Sanitary District. So they own and operate their sewer systems. We collect the flow from the low point of their system, pump it to our treatment plant, and treat it for discharge into the bay or into recycled water for the city of Redwood City. So our average dry weather flow is about 13 million gallons per day. When it rains, we get a lot more. Our treatment plant is sized for a peak flow of 80 million gallons per day, and our conveyance system is designed to convey and store up to 108 million gallons per day. So that's a big difference between dry weather and wet weather flows. Just a little bit more. This is our service area, just to give you more of an idea of where we are and who our customers are. About 220,000 people, mostly residential and commercial. So I'm here to talk about our conveyance system, and these pictures are pictures of basically our failing force main. So the force main, the pipeline that takes the flow from each of our member agencies to our treatment plant was built in the late 60s. We were needing to operate it at a higher pressure than it was designed to be operated at in order to get the flow to our treatment plant. And we experienced several leaks in the system. And for a while it was cost effective we were sending operators out the entire length of our force main every other week, looking for evidence of a leak, so that we could, quickly address it. We would have two 2 a year in the 2000s. It got to a point where we knew we needed to replace our force main, as well as upsize and replace our pump stations that pump the water to the treatment plant. So Dennis mentioned that putting pipes in the streets might be more difficult than convincing people to drink potable reuse, and that may be true, because it's disruptive, it's expensive, but it's a necessary part of life. So we underwent what we call our RESCU program, and every good capital improvement program has an acronym. So we are Regional Environmental Sewer Conveyance Upgrade, RESCU. And 10 years into the program, and I still have to look at the words in order to be able to tell you what the acronym stands for. So it's written out there for my benefit as well. And so this is the extent of our conveyance systems. We have one pump station for each of our 4 member agencies, and right now a force main that connects them all and brings them out to our treatment plant, which is out at the end of Redwood Shores. And so in looking at this program, we split it up into 3 separate projects. The first being our front of plant project, which is a headworks and a lift station that can bring the flow up from underground and up to the surface for our treatment plant. And then the headworks is actually, it's a typical process at a wastewater treatment plant. It removes big materials, sand, grit, rags, baby wipes, lots of things that people flush that we'd rather they not, but basically protects the remainder of the wastewater treatment plant. Our treatment plant was designed without one, and so since it's been in operation since the early 80s, we've operated without a headworks, but we're really looking forward to having a headworks in front of our plant. The big project is our gravity pipeline project, and that's this green line. And so what we did through our planning process was really look at all of the options for conveying water to our plant. One of the options, the one that ultimately we went with, was to build a very large diameter tunnel using a tunnel boring machine, tunneling through the ground, which had a few benefits. One of the benefits was we didn't have to tear up Redwood Shores Parkway to build a large diameter pipeline in the street. We knew that would be disruptive. We wanted to be able to limit the impacts to the residents of Redwood Shores as much as we could. Another benefit is it's a large diameter, basically a large diameter sewer. It's 11 feet diameter, and that can provide storage of water during the storm flows that we experience. And it actually, turned out to be cost effective when compared to some of the other alternatives that we were looking at. A benefit of the gravity pipeline is that we will be able to demolish our Belmont pump station and run just a sewer to get to the tunnel location, and then also the San Carlos pump station can go away as well. So we have fewer pump stations to operate in the future. So that's part of our pump stations improvements project. We'll be changing the uses at these 2 sites. We are building a brand new pump station right next door, like 5 feet away from our existing pump station at Redwood City. And then at Menlo Park, we're able to rehabilitate that pump station. So basically just take everything out, all of the pumps, all of the electrical generator, everything, and replace that within the existing structure. So I want to just talk a few things about the program. At the beginning of this program, we set up some success factors that under the categories of cost, operations, maintenance, safety, schedule, and stakeholders. And stakeholders was kind of a big category for, public, the environment, the regulatory community. And that was a really important key towards getting our minds straight, setting our North Star, figuring out, how we were going to make our decisions as the program went on. I also want to highlight that partially due to very good timing and partially due to very hard work by our finance department and the finance departments of our member agencies, we were able to take advantage of, I was trying to use this thing. Hold on, very low interest loans to be able to fund the majority of the program and be able to reduce our financing costs on behalf of our member agencies. Another thing that's different about our program is that we use progressive design build construction methods for our projects. And that's a process where you bring the contractor on board during the design phase, very early in the design phase. They're involved during the completion of the design and then the construction project. We did that for a lot of reasons. For this program, the first, there are so many smart contractors out there. There are so many good contractors out there that, they get a set of plans and they go, I can't believe the engineers thought we could build it that way. Like, let me tell you how we're going to build it, And so to be able to have that input early in the design process, the input of both the contractors and the contractors' estimators to be able to really help our decision making in terms of, how much the program, how much the decisions that we were trying to make were really going to cost us in the end. This is a very transparent process, very good in complex projects, gives us cost certainty and schedule flexibility. There are a lot of good reasons that we chose that project. So I'm going to talk a little bit about each of the program elements. This is the big gravity pipeline. That is the front of the tunnel boring machine that was digging under the streets of Redwood Shores. This is a picture of our launch shaft. So the stats are, it's about 3.2 miles of tunnel, 16-foot diameter, 16.5 foot diameter TBM. And then what we did was we launched it here from near San Carlos Airport and took a first pass this way towards Inner Bear Island. At the end of Inner Bear Island, we pulled it out, put it back in here, and then went the rest of the way down to the treatment plant. So inside the pipeline is an FRP, fiberglass reinforced polymer pipeline that's 10 and 11 feet diameter. It was actually manufactured in Indonesia and shipped over here. And so that was placed inside the interior of the tunnel. Our front of plant project, as I mentioned, this is a deep, large lift station that pulls the flow out of the deep tunnel and into our new headworks, which provides screening, grit removal, and an odor control process and is becoming the first process of our treatment train. And our pump stations improvements project is, as I said, we're rehabilitating the Menlo Park pump station. We're replacing the Redwood City pump station, constructing a new sewer, and that gives us the ability to demolish 2 of our existing pump stations. So as of, was it last week? September 6th, it's all a blur. As of last week, we actually got water to flow in the tunnel for the first time. So that was a huge milestone for us. So we have flow going from this location through the tunnel to our treatment plant, which means we're also starting up our lift station and our headworks at the treatment plant. So this is, we're in the middle of our 30-day test. We're putting it through its paces. We're working with the contractor, working out the kinks of operation of the system. And we still have a bit more work to do, but our pump stations improvements project, we're about a year out from completing that one. So we're close to the end of this 5-year construction program. So right now, this is illustrating kind of graphically the flows from West Bay Sanitary District and Redwood City previously went through our force main. This is depicting our force main. San Carlos and Belmont flows connected to it, and then it would go to our treatment plant. So now our current operation is West Bay and Redwood City flows are going through our tunnel, through our lift station, through our headworks. San Carlos and Belmont flows are still going through our force main, so we kind of are in a hybrid mode right now, but we'll be cutting over San Carlos and Belmont soon. These are some cool pictures. This was the operator out there operating the valve that was going to introduce flow into the tunnel for the first time. This is a picture of our headworks, which doesn't really have any dramatic pictures because it's all sealed up because of odors. So there aren't great pictures, but and I don't know if I can do it with this. There is a video. Oh shoot, now I did it. Okay. There is a video that maybe we need to go to the computer to click, or maybe we can just skip it. It was very exciting for me. It's the flow entering the headworks. It's probably not as exciting for the rest of you, but there it is. We had to open a hatch to get the video because everything is under wraps and under decking, but it was a big moment for us. Thank you, Dennis. Thank you. So, as I said, next steps are we're going to complete our gravity pipeline project. We're going to finish our acceptance testing for our front of plant project. Complete some last construction elements of the front of plant project, and complete and test our pump stations improvements project over the next year. And that's what I had. Happy to take questions. Yes, hi.
So when you're rebuilding all the pipes and restoring the infrastructure thing, was potential impacts from climate change being taken into account?
Impacts, the question was about impacts to climate change. Yes, they were. We have, throughout our CIP projects, we have been replacing equipment with more efficient equipment. We've been looking at ways that we can utilize the wastewater process actually produces methane, and so we've been putting a lot of projects into being able to utilize that methane and create energy sources for ourselves rather than just having to go out the flare, for example. So every element of our program, we are looking at how we can become better energy efficient. And then there are the effects of climate change on our infrastructure, as opposed to, that way, of course, that have to be taken into account as well, flooding risks, et cetera. So, yes?
Great presentation.
Oh, thanks.
Mehdi Sinaki with Valley Water.
Question regarding the financing. You mentioned $580 million for the entire improvement project, correct?
Yes.
Okay. And then 190 came from...
You're doing the math. I was afraid of that.
SRF, right?
Yes.
Okay. And then you got VIFIA.
VIFIA, yeah.
How much was the VIFIA overall?
We can go back to the slide. I don't remember. It was a big chunk of it. So the WIFIA program, we're only allowed to fund half of the program. So that might turn out, so 100, we got two separate loans, 207, and then an additional 69 a couple years later. I think that adds up to about half of the program. So you're only allowed to fund about 49% of your construction project through WIFIA. State revolving fund has the lowest rates, but they also are a bit limited in how much they could give out. So it was like as much as the SRF money as we could get, plus WIFIA is the majority of it. Some of the infrastructure was funded through cash as well as some bond proceeds.
Quick follow-up, was the SRF through CW SRF?
Yes,
Oh.
yes.
Well, thank you, Kim.
All right, very good.
Actually, so with the rescue program hitting this kind of these milestones, what are you looking? You certainly still have a lot of projects going on.
Yeah, we have a lot of projects going on. We still have a bit of rehabilitation of our existing processes. We're also looking forward at nutrient removal. So right now we don't have any processes that remove nitrogen, ammonia and nitrogen from our wastewater. And we're working closely with the regional board to plan for the projects that will ultimately be providing that nutrient removal.
And you have SVCW has a long tradition of kind of domiciling interesting technology companies, going way back.
Yeah.
And so you've taken over the Bioforce Tech
Yeah.
dryers, perhaps you just briefly mention that?
Sure, yeah, we had a company called Bioforce Tech approach us 10 years, maybe more, 12 years ago, with a technology for drying the solids that come out of the wastewater treatment. So ultimately, the treatment plant has water that goes into the bay, and then solids that have to be trucked off for go to the landfill and other applications. They had a technology that they wanted to pilot with us, and they basically grew their company through gradually upsizing their equipment at our treatment plant site. It's called a bio dryer. And it's working very well for us, and we actually purchased it from them, and we're in the process of transferring operation from them operating it to having our operators included as part of our process.
So you're making biochar.
We are making biochar, and so the last process of their treatment system is a pyrolysis unit, which makes biochar, which has a lot of commercial applications apparently. That Bioforce is taking it from us and marketing it in many different locations. Two other kind of
future questions. Well, one present. You have these things called Fournier dryers.
Yes.
Dewatering system.
Yes.
It looked very interesting to me.
Are.
So I just wondered if you can comment on that. And then I would throw out just a very, very brief thing. Last year, I think Arvind was talking about the plans for a purified water plant. So,
Yeah.
I mean, whatever you'd want to say as far as an update on that. So.
Sure. So the Fournier presses that we have, that's actually just upstream of the bio dryers that we were just talking about. This is what we call sludge, the solids that come out of our digesters at our treatment plant. Has a high water content, and in order to dispose of it, we want to get as much water out of that as we can. So we used to use a centrifuge, spin it really fast, and the centrifugal force separates the water from the solids. And that was very energy intensive. And so when we went to replace it, we replaced it with these fan presses that are much slower and provide just as good dewatering, but using a lot less energy. And yes, we have been and are continue to be in talks with the city of San Mateo and SFPUC and other water agencies in the area about a potential purified water project. So our treatment plant and San Mateo treatment plants would provide the treated wastewater to be purified at a purification plant and sent somewhere, we're not sure where, into the water system. There's an IPR and a DPR option that are currently on the table for the ultimate use of that water. So we're really thrilled to be part of that program as well.
So it sounds like you'll have things to do.
No, I'm not worried.
So thank you very much for updating us. I mean, this is a rescue, I could tell you, I've been visiting it. It's massive, multi-billion-dollar program.
Yeah,
and
it's big.
so I'm glad you're on the other end of it.
Yes, thank you. Me too.